So we're going to talk about the relation between pH and pOH. So what is pH and pOH? We have seen previously what is pH and pOH. So the concentration of the H plus into the concentration of OH minus, that is equals to Kw. Kw equals to ionic product of water. Kw is the ionic product of water. Right, similarly we have seen Ka, Kb and Kh. So Kw is the ionic product of water. When Kw is a constant, so we know Kw is a constant, use numerical value depends only on temperature. Its numerical value depends only on temperature. It doesn't vary with the amount of water, and value depends on the concentration, not concentration, temperature of, okay, the temperature. So like at 25 degrees centigrade, we have a 25 degree centigrade surrounding. The Kw is 10 to the power minus 14. So we know room temperature we take generally as 25 degrees centigrade. So the Kw value turns out to be 10 to the power minus 14. So we new term pKw. What we have seen? We have seen P. Whenever we apply P before any constant, that means the negative of log of that particular constant. So that will be equals to minus log of Kw. That is minus log of 10 to the power minus 14. So pKw turns out to be 14. So that is pKw. Further, when we take log of both the side, we know log of H plus multiplied by log of OH negative, that turns out to be log of Kw. We have taken log on the both sides. Now we are using the property log A multiplied by V, that way equals to log A plus log V. It's a very basic property you might have learned in logarithm. So log H plus log OH negative, that will be equals to log of Kw. Now if I multiply both the sides by negative, minus 1, so that becomes pH plus pOH, that is equals to pKw. So this is the relation between pH and pOH, that pH and pH turns out to be pKw. So when temperature is 298 Kelvin, pH plus pOH turns out to be 14. So pH value varies from 0 to 14. pH value varies from 0 to 14. Could pH be less than 0 or greater than 14? Yes, it may be. So I am writing the condition only when the temperature is 298 Kelvin. So pH can be negative or greater than 14. pH can be negative or greater than 14. So what could be the relation between Ka and Kb? What could be the relation between Ka and Kb? So let's say we have acetic acid CH3COOH gives CH3COO minus plus H plus, that is a Ka. Okay. Now this is acid, this is a weak acid, so that will be conjugate base. No, not we are talking right now here about the strength. We are writing it as an acid and it is its conjugate base. Now, when conjugate base CH3COO negative, we are calling it as a base. So it might be, it must be releasing OH negative. When we reacted water, when we hydrolyzed it, it gives us acetic acid plus OH negative. So that turns out to be Kb. Right, this is Ka and this is Kb. Now, we can't take Ka and Kb randomly. What I mean to say, if you are using the K of a particular acid, then the Kb must be for its conjugate base. In the relation, we have seen Ka into Kb equals to Kw. So that should not be randomly Ka and randomly Kb. If acid is Ka, then its conjugate base is hydrolysis, or we can say constant should be Kb, right? Now we know H2O releases H plus and OH negatives. That turns out to be K into Kb. So we know Ka of A and Kb of conjugate base turns out to be Kw. And we know Ka of conjugate acid into Kb of base turns out to be Kw. If we have acid, then it will be conjugate base. And we have base of, we can say, conjugate acid. We can start with anything. It could be either acid or could be base. Now, if we take logarithm on the both of the side, then pKa plus pKb turns out to be pKw. So if I write the value of, that was the relation that we are trying to derive. And we have seen and look at it's one of the example, or you can say application, right? Now, pKa equals to negative of log of Ka. So Ka is inversely proportional to pK. Whenever the value of Ka is increasing, the pK is decreasing. So as Ka increases, pKa decreases. That is called a strong acid. And when Ka is decreasing, pK is increasing. That is called a weak acid. So pK of any acid is higher. That means that is a weaker acid, right? And similar, we can say pKb, negative log of Kb. So Kb is 1 upon pKb. So Kb is high, pKb is low, then it is called strong base. If Kb is low, pKb is high, then it is called a weak base. If K is, what is the categorization? What is the, we can say, limiting value of K? So whenever K is value greater than or 1, we call it as a strong acid. We put in the category of strong acid.